Hi, my name is Nicholas Francis, and myself, along with Dr. Stockton Maxwell from the Geospatial Science Department at Radford University, did this project on dendrochronology in Southwest Virginia. This video will be looking at some of the supplementary images and the main takeaway from the project. So, this first image, figure 2, shows the master chronology for the Roaring Branch Eastern Hemlock Study Site. The ring width index, which is the darker gray line, represents the average growth at the site per year from an average of all the trees, with the decadal changes shown by the red line. So kind of an averaged out, smooth curve, growth curve for each decade. Sample depth is the gray shaded area, and it can be seen to decrease back in time as the sample depth, of course, decreases. We have a total of 46 samples from 23 trees. So as you can see, just before 1950, or just past 1950 rather, you can see that there are all 46 samples in the chronology. But as you get closer to present day and farther in the past, that number decreases. Now the number decreases as it goes further in the past just because simply the trees aren't that old, or the core had a problem and we weren't able to, say, get past a rotten section, we weren't able to measure past it, so we just cut it at a certain point and measured it to that point. But the core depth does vary from tree to tree, which results in kind of the stair-step type curve going back in time for the sample depth. Now, as it gets closer to present day, this is a little interesting because in this region, in the Jefferson National Forest, the hemlock woolly adelgid killed a lot of these trees in the past. So one thing that we had to figure out in our analysis was when these trees died. So as you can see, some of these trees died in, say, 1960, but they were cored in 2018. And then, like the graph shows, a lot of the trees did die closer to 2018. From 2000 to, say, 2010 was when a lot of these trees died, and we did have to figure that out as part of our analysis. Figure 3 shows the growth curve for each tree core sample in the site chronology. Now you can see that some trees show more variability that can be attributed to forest disturbance rather than climate. So you can see in the early 1900s, between 1900 and 1950, a lot of the trees responded to something that happened in that area. Now we don't know exactly what that was, but it was a disturbance of some sort. These variations in the curves were removed to try and hone the climate signal. So, like I said, in between 1900 and 1950, there's a little noise right there around 2000. And again, in about 1850, which shows that something happened, like I said, in that site around that time. So now we're back to the main poster, and the main takeaway from this project is that old growth eastern hemlock trees in Southwest Virginia respond to changes in temperature but not precipitation over the past century. So I have a results video that you can go check out as well, but basically the general idea of it was these trees showed a strong correlation between temperature and growth as opposed to precipitation and growth. There wasn't a strong correlation between precipitation and growth. So why should you care about this project? I mean, a couple of nerds looking at trees, I understand why you're curious about that. To understand the past is to be able to predict the future. And what I mean by that is, When you understand the past, you can begin to piece together the puzzle of what could potentially happen in the future with climate change, with disturbances,